Today we are performing the breakover voltage of given DIAC from its VI curve. Experiment number 3. DIAC is a full wave bidirectional semiconductor switch. Because of its symmetrical bidirectional switching characteristics, these are widely used in triggering devices in the DIAC phase control circuits employed for lamp dimmer, heat control, universal motor speed control. In this practical, student will be able to find the breakover voltage of the DIAC. Here in this experiment, we are observing the DIAC characteristics. This is the circuit diagram of our experiment. In DIAC characteristics, we are connecting DIAC here, MT1 and MT2. These are the two terminals of DIAC. Here is voltage supply of 0 to 50 volt, variable voltage supply, then resistor, then here we are connecting the milliampere meter, then MT2 is connected to the positive terminal of the supply voltage, then MT2 is connected to the ground, then voltage is calculating across the DIAC. Then these are the resources used: digital multimeter, DC power supply, DIAC. We are using DB3 type of DIAC. Then resistor, we are using 10 watt of the resistor. Wattage of the resistor is 10 watt using here. Then connecting wires and breadboards. This is our observation table. First one, in first observation table, our MT2 is connected to the positive terminal, then MT1 is connected to the positive terminal. Today we are performing the DIAC characteristics. DIAC is a bidirectional device which is having two terminals, MT1 and MT2. This is the kit for VI characteristics of DIAC. It is having two terminals, MT1 and MT2. DB3 DIAC we are using here. We are connecting power supply here. Then 1 kilo ohm resistor we are using here. Then we are connecting the milliampere in series here. Then we are calculating the voltage across the DIAC by connecting the multimeter. DB3 type of DIAC we are using here. These are the internal components. This is a DIAC which is having two terminals. Then these are resistors connecting in the series. We are giving high voltage which is 62 volt here, so we are using high wattage resistor here. Around 10 watt resistor we are using here because current capacity which is bear by resistor is so high, so we are using here 10 watt resistor. Connecting in the circuit, let's start the connection. Here DIAC is triggering around 32 to 36 volt, so we are having here 32 volt power supply. So using in the series connection, we are doing the connection. Channel 1 is used as a master and channel 2 used as a slave. We are connecting both the channels in the series, so we are getting addition of the voltage for triggering purpose of the DIAC. First, channel 1 is using as a master and channel 2 is using as a slave. Positive terminal connected to the channel 1. These are the two knobs which are setting on the series. Positive terminal is connected to the channel 1 and negative terminal is connected from the channel 2. These two connections are giving to the DIAC. Here DIAC is both directional we are using. So first we are giving the positive supply to the MT2 terminal. Here we are giving the 2.2 volt, means 4.4 volt supply we are giving to the DIAC, which is addition of the two channels. Now we are connecting the multimeter here. First we are giving the positive supply to the channel 2 MT2 and negative supply connected to the MT1. This is the observation table for when MT2 is positive. Then we are calculating the V21 and I21. When MT1 is positive, then V12 and I12 we are calculating. Here we are taking the difference of 0 volt, 15 volt, 30 volt, because DIAC is turning on at 34 to 36 volt, so we are taking the voltage difference around 15 volt, 0 volt, 15 volt, 30 volt. Let's check first observation table where the MT2 is positive. We are varying the voltage and calculating the current. This is MT2 point is connected to the positive power supply and MT2 is connected to the negative of the supply. Positive connection from channel 1 is connected to positive supply to MT2 and negative is connected to MT1. Now we are connecting multimeter here, milliammeter and voltmeter. These are two digital multimeter here. DC supply we are giving, so knob is on DC, then milliampere. This is milliampere meter and this is a voltmeter. So knob, positive knob on V, DC voltmeter. These multimeters points are connected in the circuit. Initially knob are on 0 condition. If we are giving the high voltage, then DIAC may be burned. So before power on the supply, check the voltage knob. Now we can vary the voltage and measure the current. Slowly we are increasing the voltage. Here 5.5 means 11, around 11 volt. 11 volt supply giving to the DIAC, but current is 0 at this condition. Current is 0. Now we are increasing voltage again. Addition of the 5.5 plus 5.5 is 11, showing here on the multimeter. Now we are increasing the voltage again. Here 14, 15, 20, 31.2. At this point also the current is 0. Now we are increasing the voltage slowly, because at 32 to between 32 to 36 trigger DIAC will be trigger. So we are increasing the voltage slowly. 34, 34.4, 35 volt. Suddenly our voltage is decreased at 29 volt and current will be increased at 5.7 volt milliampere. Sorry, current will be increased at 5.7 milliampere and voltage will be decrease on 29 volt. So now we are trigger the DIAC at point of 34.3. At the condition of 34.3, current will be 0, and suddenly when the DIAC is triggered, our voltage dropping to the 29.1 and current will be 5.7 milliampere. Voltage decreases and current will be increased. Here we are taking 2-3 readings. Now our voltage is decreased and current will be increases. We are taking 27 volt. At the point of 27 volt, at the point of 26 volt, 18 milliampere, current will be 18 milliampere. Then 25 volt, current will be rapidly increases. At 24 volt, current will be increases 36. Now we can minimize the voltage because excess current cannot bear this circuit, so we are minimizing that. These are our readings. When the this is VBO 34.4 volt, then after 34.3 volt, voltage will be decreases and current will be increases. These are the readings for when the MT2 is positive. Now we are doing the MT1 is positive. Just reverse the connection here. Positive terminal is connected to the MT1 terminal, and negative supply is connected to the MT2. We are just reversing the terminals of the power supply. So now we are calculating the V12, varying the V12 and calculating the current for V12, I12. Initially the voltage will be 41 volt. Around 30 volt, current will be 0. Negative supply going here at the MT2 channel, and positive supply going from the MT1 at point 31 volt. Current is 0. 33 volt, current is 0. At 34.10, same 34.3 volt. At the point of 33.4 volt, suddenly voltage is decreases and current will be increases. Here the readings 34.6 volt. At 34.6, or we can say 34.5 volt, suddenly the voltage is drop and current is increase at 10 milliampere. 23 volt, voltage is 23 volt and current is increases rapidly. Here voltage is 23, current is 13 milliampere, then 22 volt, 16 milliampere, likewise current is decreases and voltage is decreases and current is increases. Same as the characteristics for MT1 and MT2. By using these two observation table, we are drawing the graph as the VI characteristics of DIAC.